Okay, I'm Mark. I'm a senior solution specialist in Bentley systems, and I do support other products like OpenCity Planner, ContextCapture, and OpenCities Maps. So all three products that we're touching today. First, I want to talk a little bit about a digital twin. So we're working with different cities and different type of users, not only cities, but campuses type of users, mining companies. But for example, what we learned from Singapore and Dublin and Stockholm and Helsinki, that there are so many different use cases. So for example, Singapore, they have a lot of data silos between different departments, different government departments. So helping building a digital twin where every department put data in will help to break down the silos. They do it basically project by project. And for them, it's also really underground is important. And we don't really have underground examples today, but underground is also one of the main things what cities are using for the digital twin. And Dublin is, for example, different use cases. They do a lot of events, what they need to host and manage. They're using a lot of open data, and they do resilience with flooding. While Helsinki, on the other side, is more using a citizen engagement. It's really important for them. They do a lot of planning, rebuilding the city. So they're doing a lot of planning, and they do also, more environmental data sets. So if we talk about digital twin, people most of the time thinks about engineering, information operations. What we see from Bentley is that using context, so spatial technology, is really a good driver to really get started. You can build up really quickly a digital twin, and then you can start from there. I think I skipped one too much. Yeah. So if you want to make a transition from document-driven to data-driven decision-making, so how can we help with this? So yeah, you have your key documents, drawings, models, and maps, and they are basically all made of layers. It's a similar way you can think of digital twin is make up on layers of data. So for example, you see here a quite common type of data set where you see asset performance optimization, IoT data, 2D and 3D CAD file, GIS data, reality modeling data. So they all come together in a digital twin. And each layer basically updates over time. So each layer has its own frequency or updating. So aerial imagery, you do maybe once per year. Drone data, you do, let's say, every quarter. IoT data is basically every minute updating. And so this is something we support in a digital twin. And so this is let me see. So this is how can we help starters. So what we often use with most of our users is a maturity model approach. So then you increase your value from digital twin over time by adding more layers. So we choose normally a couple of layers, but we start with quite often is that reality data and GIS data and BIM data. And then we choose the layers in order to get the fastest benefit for a large number of users. And then we have a system where we start adding data, and in a couple of weeks you're up to a digital twin. It's not like in the past when we take months to build something, it's really quickly to build on data. So this is for an example we quite often use with our users. We do a kind of a workshop where we check which data layers to start with, what's important, what type of data do you have, and then basically we just do it at the state that it is at the moment, and then we start adding more layers over time, and then increase more, for example, resolution of each layer, and then increase frequency of updating from each layer. And at the end, we start building applications for each layer, more connection between the layer and multiple layer applications development. So that's a little bit the way we approach a digital twin, or we can approach a digital twin. Well, what's quite important, an easy way of starting is a reality modeling. So reality modeling is a technology where we can quickly produce 3D models from, now we're talking about cities, but it can be basically anything. And you do a site capture and process the data, and you can quite quickly, you can use the data already in digital twin. The way it looks like, you have your photos. Most of the time, the photos need to be geo-referenced. If you fly with a drone, most of the time are geo-referenced, but we can also use ground control points. That's something we suggest anyway. And then you get a mesh model out through the ContextCapture, and then we have some different workflows where we support. We can mapping, surveying is a common one, asset inspection, construction monitoring, digital twin. And when there are many more different applications how users are using ContextCapture. And the way it looks like, you have a camera and you capture data with a certain pattern, with a lot of overlap. And you can do with a handheld camera, you can do with a drone, and there are different flying patterns for different output resources. So if you do, for example, for mining companies, they quite often don't really need the highest resolution. So what they do, they have, for example, fixed wing drone flying up and down with a single camera on it, and then you get a data set out that is sufficient enough for their workflow. But if you want to do an asset inspection, or you want to do more with the data, then you have to fly in different pattern or using different type of camera. And then also bigger cities are often do with data sets from a plane, so they fly with a plane. They can capture more data, but quite often you will see, I've got some examples, the resolution is a little bit less than if you do with a high resolution with a drone data set. It's all whether you want to use the data for. And these cameras are more specific that we don't, there are here in Australia are a couple of companies who are using a plane for doing that. So that not everybody can afford and have work enough to use a plane, capture data with a plane. So the principles of ContextCapture of photogrammetry software, we recognize pixel on pixel and we match stitch photos together. So the workflow is you put all your photos in ContextCapture as an import. So basically you drag it in, you run a process we call aerial triangulation, where we try to stitch all the images together. And then we do that on RGB values. And every point you want to model, you want to recognize, needs to be in 3 photos at least. And then of course there are different capture techniques from different type of data sets. Sometimes it's easier, sometimes data sets are more complicated. If you have a lot of glass or so, then it's more complicated than if you just do an outside and train. But after import aerial triangulation, we and comparing of the photos, we make a mesh and texturing, and then the output can be a mesh model on different formats, but it can also be in point cloud as an output, also as an input, but also as an output, and also photos, of course, the DTMs. So this is a little bit an overview again from what type of cameras we can use. We can use things even like a phone. You can really get good models out of the phone. Smaller models, of course, but it's because the distance to the object is quite close, you get good results. Digital cameras, drones, different type of drones, and a camera under a plane. And of course, a combination of these data sets. Quite often what users flying with a drone, they also walk around with a handheld camera and merge the data sets together to get a better result. You can only model what you see, and you can imagine if you fly with a drone, you can't see everything under certain, let's say overhanging objects or so. There's no capture rules where you can use different objects, and I think it goes too far to go now more in detail. If you want to have more detail, we can provide that. We can do a session, but basically some of the rules are 70-80% overlap between the photos. Think about every point need to be in 3 photos, but also different angles to the object. So if you go here, you see, for example, if you want to do a building, you want to do a really nice site of the building, you have to fly lower and capture the data over there. One of the most quite common technique and really good technique, because it's flying orbits with different heights and different distances to the object, and it works really well because what you do, you capture a lot of points from a lot of what we call tie points if you go around the area. It's not a really easy technique to use because it's not really supported by flight planning software, but it's a quite common way of doing a really complex things like a planned site or so. Also, if you want to have more detail, we cannot really zoom with the camera. Let's say you walk around with a handheld camera, you can't really use a zoom option. So what you do, let's say you do the outside first, then you go closer. You want to have more details on this headlight, you go closer and get more details. But what you then need to do, you need to have an extra step between if this gap is too big. Again, one of the capture rules. So over here, you see an example, a couple examples from how data is captured. I didn't show really a full city model because city model, it depends on what type of camera you're using. I will explain it in a minute. But we can also do things like cell towers, so communication towers. So you see these are really thin objects around it. So you need to fly, like what you see, flying orbits around and shooting inwards with a certain angle to get more detail from it. If you then on the other side, if you do a mine site here, for example, you don't really need that many photos on objects. So you fly, they fly in just a pattern like this or up and down. You're shooting images nadir straight down. The same as here, this is a campus building. So you see over here, they do a big area, they're flying a little bit higher. So the software really likes it if you fly higher and then lower, multiple different distances to the object. Makes it easier for stitching everything together. So they fly higher, they fly a little bit lower, and then they fly orbits around the buildings to get more detail. And yeah, you can imagine if you can only see from the top, don't see the side of the building, then the result won't be that good. You can't really see the side of the buildings. If you do bridges, for example, that is also quite complex because in a bridge, in the photos from bridge, quite often sky and water. If you want to go too low and you want to shoot under the bridge, you face the camera up. So you see a lot of sky in the photo. It's really hard for stitch together. But if you going too much down, you see a lot of water in it. It's also difficult for stitching photos together. So there's a certain flying pattern, and we really have to cover that well. We see really good results from our users how to capture bridges and also all the other objects. So for example, this is if you do on plant site. We have also oil and gas users who are capturing the whole plant site, so they walk around often with a handheld camera. And then they also fly a pattern like this, circles, different heights, and all facing inward. So we create so many different type points what we use for stitching images together and get a good result. I got some couple of videos on models. So this is one of our users in Australia. This is Aerometrics. It's one of our bigger users. So they fly quite often. They use helicopter. They also use planes. It depends on data, but this is a helicopter data set. And it's not only from so they fly in pattern with a helicopter to just hang out of the door shooting images. With just they use, I think, a 35 megapixel camera, but maybe also they have 61 megapixel cameras and 80 megapixel. But what you see over here, you can also see under the buildings, under the rooftops, under the, what is it, level. It's mainly because they walk around with a handheld camera. So they not only doing from the helicopter, but also with an merging with a handheld camera. So they just walk around shooting images, and with a certain workflow, we can merge them together and process. Another thing what you see and what you don't see is you don't see cars and people. So what they do, they also really clean up the data. So they process, and we have a workflow in ContextCapture where you can remove objects, for example, like cars, people, a lot of noise. Sometimes you see a little bit noise in the model. And this part is most of them is a manual process, but it really adds, yeah, you can see this almost photorealistic models out of it. So it's all doable. It's just about how to capture, and the processing isn't quite, it's the easy bit. The capturing is probably things where you need to think about output focused. On the other side, this is a drone capture. So this company, what we work with is a Bentley partner. They have a camera system which you can use on the drones, and there's a 5 camera system. So the flying is just up and down. It's easy. You don't have to do, yeah, no special flight, just a normal up and down flight. But they shoot 5 photos each time. So they shoot 1 photo down, 1 left, 1 right, and 1 forward and backward. And they're flying, you see, 117 meters high. I wrote it down. And there's a GSD, count sample distance, from 1 centimeter. So this is a camera system, what we see that a lot of use in China. They're flying up and down, and in China it's quite normal that they fly in city multiple times per day. And yeah, you see the results. It's, yeah, you can't really go under things like what we do with a handheld capture, but it's coming quite close, I think. There's a really good example how to build up a digital twin from a city quite quick. So you can do the same with a normal single camera on a drone, but you have to capture way more images. Flying more time, I'm not sure if it's more images. But if you see the result, I think it's quite good with this type of camera. So this is something we see more coming in the users start using this type of cameras, also on fixed wing drones, not only on rotor drones, but also fixed wing drones. And yeah, you can see if you go here, you can see we can't, it's not like the handheld capture, you can't really see underneath this object, but it's coming quite close, I think. Next one. So this is this is completely the other side. This is from a plane. So this is New York, one of our water saying companies, Nearmap. They're using a plane. They're flying quite high, but they capture really large areas per day, and also processing in ContextCapture each day large areas. But you also will see the resolution is not as good as the 2 other models that we're using. So this is the statue just to show that it's you see all the people standing there. So you see all water objects over there. So what they do, they just capture, upload the data to the cloud, process, and get a model out. They don't remove all this. For example, on the side, you see the water objects or the people, but that's not a workflow. It's just want to show that ContextCapture can handle this different type of data sets, and it's all the same software. So it's yeah, you can see it looks quite impressive to have a large data set like this. But you see the roads, yeah, the quality is a little bit different than the quality that I was showing before. Let me skip this one. So this is another example, nothing to do with cities, but how our users are using ContextCapture. We see a lot of cell tower applications. So we're using, for example, I think it was 1400 photos. We fly with a cheap drone around at different angles and create a model like this. We have software where we can do machine learning and then detecting what are the antennas, the angles, and all that information. But this is just the model that I created. So you see here examples. And of course, this requires a completely different capture technique than if you use, for example, for a city. Yeah, so considering the time, let me skip this one. So this is another really nice example. This is an uranium plant in South Australia. And what the user wanted to do is they want to create a digital twin of their plant site, but they want to read these tags on the pumps and numbers. So we fly with a drone and then we walk around with a handheld camera while we're merging the two data sets together. So that result, reading that number, for example, it's really hard if you want to do that from the drone. You have to come really a good camera to achieve something like this. But what you can do, you can walk around with a handheld camera. It doesn't have to be geo-referenced, as most of the time the handheld cameras are not geo-referenced. And then we can stitch the data sets together and then produce a model out of it. So this is, yeah, and then different use case, but we see like a lot of users are using it on this type of data sets, pump sites, building digital twins, so you can read the number of the pump in a model. So merging drone and handheld, there's another workflow what we can use in ContextCapture. And then something different again, this is an photo data set from not geo-referenced. We geo-reference based on these QR codes. We have some users doing this if they open, for example, we have an airport user, when they open a pit like this, what they do, they capture data sets just with the phone, and then they have they build up a history from these objects. So it looks quite easy to use. Got some other example I don't have video from, but that we're also using video as an input. So we have, for example, if you're using ground penetration radar, what you can see with the red paint on the thing, I think they use ground penetration radar to detect where the utilities are, the pipes are. Then something we have a user will walk around with a video camera we process. So they don't have to send a surveyor team in to measure this, the lines on the road. So we can also, ContextCapture can handle photos as an input, point clouds, and also video as an input. And point cloud can be mobile scanner, but can also be just a static scanner. So there was a little bit about ContextCapture. The other application we were showing was OpenCity Planner, and OpenCity Planner is our cloud-based application. And the name Planner means we used to use that mainly in Scandinavia as a Scandinavian product for planning solutions. So you have a whole city model, you want to put a new building in, you can flatten the building in the viewer, the mesh model, put an Collara or BIM model in, and then you can planning. But now we see we're building it now, we're using it really for digital twin type of input. So we see some use cases, we call it now OpenCities 365. So of course, still we do the planning, solution, citizen consultation. If there's development, you need to approve it. You can have different alternatives in a web viewer. Tourism is in a use case. Virtual town hall meeting, so we can download all the data. It's cloud-based, but we can download the data on the computer and use it from there. But we see also event planning, fire services planning. For example, Dublin is doing that. Security services. We have airport users using that for asset management. Different portals, so we can create a portal. If you, I will show later an example on portal. If you maintain a lot of objects, you can basically, let's say countrywide, you have a map, and then you can drill in and see all the projects that you're managing or quick overview how if you have reality modeling data, you have a spatial database. Well, of course, I think most of what we show later is that we use some shape files. But if you really have a production environment, we often use spatial databases. So you have a spatial SQL or Postgres. You update and maintain the data with OpenCities map, and directly it's publishing also directly in OpenCities Planner. And we can also load CAD files, Revit models. We use an iTwin services from Bentley for it. So these are some examples. So this is a data set in France where we have a whole city model, but we don't have all vector data from all the buildings, but we overlay a building footprint with information. So we have a layer building footprint. You can select, see the attributes. So these are some of the projects that they're doing. Another use case is land management. We do that in Dubai. You see, they have data sets. You can select and view the data, and then you can search for data. 3D cadastre will also be a really good use case for using this. So another example. So let's say you want to do a development of a building, and how you want to publish it out. So for example, here we create something, you go in the building, use some SketchUp models. There's probably SketchUp models where we can go in, you can see the information. And how does it look like if you're in the building? You can view out, see how the view looks from this new design building. So this is one of the use cases we're using also for. We can use IoT data sensor information, for example, where you click and see information. We have a city in Australia is using it for park spaces. So they have sensors. You can basically click on a park space and see how many space, park garage, and see how many spaces are left. This is a digital twin environment from Microsoft campuses in Singapore, where we link sensor information like the power uses, life, the energy using. But they have also sensors if you can see if somebody is in that area or not. So you can see OpenCity Planner is way more than just displaying and data set. We can link, for example, to BIM models. This is an application that comes with our iTwin. It's a really technical iTwin viewer where we can do things like slicing, for example, of your BIM model, but we can just display it in OpenCity Planner. Other use cases is viewing, for example, 360 images and point cloud data, where you can obviously here we overlay the data from a point cloud viewer, also Bentley product is Orbit, on the top of the mesh model. Let's go to the next one. So this is an example from a user in Australia. It's a school. Yeah, they maintain a lot of schools in New South Wales, where they have, for example, this is a new design, and I don't show all the data, but we do also a lot of underground utilities for them. You just see here it's mainly showing that some BIM model where we load directly, so there's no loss of information. We can set up some viewpoints. So this is not only for the people working, but also for the students, where we can link some information to it. So this is quite simple, linking a YouTube movie to the information. So you go here, and this is all information from this school. And we set up different viewpoints, but you can still zoom around yourself. So this is all in a digital twin view. We have different ways of working with this type of data. So normally we set up a lot of viewpoints where you jump right away to a certain view location. So this is a plumbing area where they learn the students how to work with plumbing areas, with toilets, for example, what we see here. And we can have different layers where you put the pipes on and see information of this object. So mechanical object, you can see the information that comes directly from the BIM model. And then we also have, I think, we have an example over here where we select and sensor information. So this is another tool of Bentley what we are linking to. So this is for the analytics, where you see it opens all the information directly from sensors, and we can display this in a web viewer. So we use OpenCityPlan as a portal to load different type of data. One more video. So this is the last one that I wanted to show. So we have some data from hospitals in Thailand. That's what we're going to present later. I created a portal. So this is a use case that you can use it. So when you start up the website, and it's a secure, you can have it as a secured environment. So nobody can log in without having access. So I add a logo on it. You can link, for example, a logo to a website. But then over here, you see the different hospitals. So I just loaded, I found some data set with hospitals, and these are not all the hospitals, but I loaded some of them, where you can see some information. You click and you see the information about that hospital. And in this case, I have as a background, I have the road map, but you can also set, if you want to have an aerial map, you can change it, or whatever map you want to have as a background map. But you see the two red objects. I make them red so I can recognize what it is. But when we click it, it jumps to the other project. So this is some of the two projects that we loaded. You see, we have some GIS data, not so much special data in it, but the thing is, you can give somebody access to the whole portal, and he can zoom in and jump to the hospital or to the object that he wants to view. So this is the other one. Click on it. It opens that other project, and then you can do your data over there. So quite often is a use is to make it easy for the user, not so many layers. Split it up a little bit. Yeah, so we're gonna drill in later a little bit more what OpenCityPlan can do, but this is one of the use cases, having a portal, for example, to do that. So this was my part of the presentation, and I think we have questions later. So if there are questions, we can talk about it later. Can you take it over?